Alright, so let's review a little bit about 1.3. In section 1.3, we talk about the slope of a line and also the form of the linear equations, right? I told you guys there are four cases about the slope of a line. We can have a positive slope, which implies a rising line, and we can have a negative slope, which implies a falling line. And again, the slope in here, it means for steepness. So if you have no slope at all, if you have like zero slope, it means that you have no steepness for the line, right? It means that your line doesn't rise or doesn't fall at all. It means that the line would just run, so right, like straightforward from left to right, just run as a horizontal line. So in short, when m equals to 0, when you have a zero slope, you're gonna have a horizontal line, okay? And because we have a horizontal line, why not vertical line, right? And if you were to get a vertical line, what is the equation of it? What is the slope in there? What is the steepness for that case? Well, for vertical line, we have no steepness, and unfortunately in this case we cannot define the steepness, because for vertical line we have a line that like goes from like the bottom to top, right? Just straightforward. It's vertical, but it's like vertically straightforward. It's not horizontally straightforward. That's why we cannot define the slope in there, and the vertical line is the only case where the linear equation doesn't have a y at all, okay? So just remember one thing. For when the slope is positive, negative, or 0, you have a y in your equation. But when the slope is undefined, you're not going to have any y in your equation. It just starts with x equal to a number, period. That's all, okay? And the second concept that we learned about in 1.3 was about the form of the linear equation. So we have three forms of linear equation. The first one is the slope-intercept form. The formula for it is y equal to mx plus b, and b in here is the y-intercept, okay? M in here is the slope, we know that. X and y is just variable. They means like for a point, but remember, x and y are not meant to be numbers. They're meant to be just variables, okay? So don't touch on x and y, okay? The second form of linear equation that we learned was the point-slope form. And the equation for it is y minus y1 equals to m, open parenthesis, x minus x1, close parenthesis. Again, x and y in here are just variable. M in here is the slope, x1 and y1. They represent a point, a given point that the problem gives us. Okay? This one to me is like the easiest one. Useful, I'm not sure, but it's like the easiest form for me to do, because you just have to write it out, plug in the numbers, and then there we go, that's it. But for y-intercept, no, for the slope-intercept form, you have to do more work to get down to the slope-intercept form. Okay, and the very last form of the linear equation is about the standard form. The formula for it is ax plus by plus c equal to 0. And in here, again, x and y are variables. A, b, c, they represent numbers. This equation, this formula in here, is the least common use among the three formulas, but it's still there, so I just want to introduce you that there are three forms of linear equations, okay? And the very last concept that we learned from 1.3 was about parallel and perpendicular lines. If you have to remember something about that page, please remember that for parallel lines, the slopes must be the same, and for perpendicular lines, the slope must be negative reciprocal of each other. So for example, let me write it in here really quick. If I give you m1, the slope of the first equation equals to, say, I don't know, negative 2, and I ask you to find the slope of a line that is parallel to this line here, then you're going to tell me m2 equals to negative 2. Why is that so? Because for parallel lines, their slopes must be equal to each other, okay? And in another scenario, if I ask you to find a slope of the line that is perpendicular to this line right here, then you're going to tell me m2, it equals to 1 over 2. Why is that so? First of all, 1 over 2 is the flip of 2. And second of all, 1 over 2 is positive because we have a negative originally from the first slope, okay? So for a perpendicular case, make sure you flip the number and then you negate it, okay? What does it mean by negate again? If you start with a negative number, then the answer would be a positive number. And if you start with like a positive 2, then the answer in here would be a negative 1.2. Okay, so that's what it means by negate. Let me put that this word in here, negate. Negate for negative, by the way. Okay, so that's enough talking about 1.3. Let's talk about 1.4, functions. Okay, good old habits. Let's review some old concept before we talk about the first objective of the day. So this page is really much just like words and words. Just read through it. In many common relationships between two variables, the value of one of the variables depends on the value of the other variable. Okay, and what I mean in here, usually the case is that the value of one variable in here, I refer to y. It depends on the value of the other variable. I refer to x, and you will see why in a moment. Okay, real life example. For example, the sales tax on an item depends on the selling price, right? So this in here, sales tax. Okay, my pen is back. Okay, the sales tax in here, it depends on the selling price. And another example, the distance of the object moves in a given amount of time. It depends on the speed. And another example, the price of mailing a package. It depends with an overnight delivery service. It depends on the package's weight. And there are many more examples like that in real life problem, right? Like the amount of hours that you study for a class. I mean the grade that you get in a class, it depends on the amount of hours that you study in a class, and like how good your food is. It depends on how much of like say salt or like sugar that you put into your cooking like recipe method. Okay, you can find a lot of examples like that in real life. It's like around us everywhere. All right, let's talk about mathematic examples. Consider equation y equals to negative x plus 3 right here. Okay, so this in here by 1.2, we know that this is a linear equation. So let me put an error in here and let me just write linear. How do I know that it's a linear equation? First of all, there's no power on x and y. That's why I know that there's a linear equation. And second of all, like it's short, right? Because there's a 3. That's a free number. So that's like more hints to tell us that it's a linear equation. Okay, for this equation, we can say that x is the input or the independent variable, and y is the output or the dependent variable. What do I mean by this? I mean like if you input say 0 for x, if you let x equal to 0 in here, what do we get for y in here? We get negative 0 plus 3, which is 3. So then we're gonna get y equals to 3. Notice that for one like value that you put for x, you're gonna get a value for y, right? So the y value in here, it really depends on whatever you input for x. If you put 0 for x, there's no way you get y equals to 2 or any other number than 3, right? Like because like mathematically, when you plug in a number, there's no other option. It's just one outcome. We're gonna learn we're gonna learn in later pages. There are more scenarios when this situation doesn't happen. But for now, for linear equation, for one x value, you can only get one y value. Okay, we cannot make up any number for y values because it's just simply the plug-in process, and then we get a number out of it. All right, next concept. Most of the relationships that we will study in this course have the probability that for the given value of the independent variable, there corresponds exactly one value of the dependent variable. Such a relationship is a function. In other words, a function is a machine that inputs values of independent variable and outputs values of dependent variable. And notice that whenever I say values of independent variable in here, most of the time they talk about x. That's like the input. That's what you plug in. That's what you can choose. And when I talk about values of dependent variable, most of the time I refer to y value because that's the value of the output. That's the value of what you get after you plug in a number for x. Okay. Lastly, although functions can be described by various means such as tables, graphs, and diagrams, they are most often specified by formulas or equations. Equations are the one with the equal sign, we know it. So this one in here is an example of the equation. Formulas in here is like the three formulas that we learned from 1.3. We have the slope form, we have formula for the slope. We have the slope form formula. We also have the point slope formula. We have the slope intercept formula, and so many more. Okay. All right, let's talk about the first objective today. Functions. Okay, a definition of function. What is a function? A function is the relationship between two variables such as to each value of the independent variable there correspond exactly one value of dependent variable. So this one is what we have like already talked about in the last page. The independent variable in here is the input, which is x, and the dependent variable in here is the output, which is y. How do I know it's so fast? Well, like if you have a problem with English like me, a quick like tip, a shortcut for this to remember is that independent is start with the I. Input it also start with the I, right? So input is like what you put in, right? So you can think of it as this like in and out, like in and out hamburger or whatever you want to call it. So in here is x and out in here is y, right? Most of the time you're gonna plug in x and get y out of it. You're not gonna plug in y values to get x out of it unless the problem tells you to do so. But most of the time you're gonna plug in x values to find y, okay, if the problem doesn't say anything. So here is the the picture of the machine of the function where x in here is the input and y in here is the output. Okay. The next concept is very important, the domain. So what is the domain? The domain of a function is a set of all x value or the values of independent variable for which a function is defined. Okay, so what does it mean by define? Define is like if I give you a function, for example, y equals to, I don't know, like 1 over x minus 2 in here. Okay, think for yourself, what is the x value that makes this function right here undefined? And what do I mean by undefined? I mean like it doesn't exist. So for example, if I ask you what is the y value if I input 2 for x, well, if you plug in 2 in here, you're going to get an issue. We're going to get y equals to 1 over 0. And this one in here is undefined, right? Like we cannot divide anything by 0. That doesn't make sense at all. So at the value of x equal to 2, this function is undefined. And hence, 2 is not in the domain of this function right here. Okay, so that's what it means by defined, undefined. Okay, the range of the function is a set of all y values or the values of dependent variable, okay? So just remember one thing, domain is x, range is y, okay? Now, for personal tips, I have to decide whether an equation defines a function or no. It is helpful sometimes to isolate the dependent variable, usually is y, to the left-hand side of the equation, okay? That means that you only have y on the left-hand side of the equation and everything else, like x number, whatever, that is not y, everything must be on the right-hand side of the equation. Okay, let me demonstrate what I just said by doing the first example. So the question is, do the following equations define y as a function of x or no? So we have the functions right here, x squared plus y squared equals to 4. If you recall this formula or this equation from 1.2, you can tell me right away that it looks like a circle. Okay, and if you remember how to identify the radius and the center of this equation, there's no number next to x squared and there's no number next to y squared. That means that h and k, the center in here, is 0, 0. And a very common mistake that I see a lot of people making on the homework, and also they ask me a lot, is about the radius. Remember, one thing about this equation is that on the right side, this number in here is not r, it's not your radius at all. Okay, by the formula, whatever number that you have on the right side at this stage is actually r squared, it's not r. So to free r in here from the square, to solve for r in here, we have to take the square root of both sides. Okay, and in here we're gonna get r equals to 2. That means from the origin 0, 0, let's make a point there for the center of the circle. We go 2 to the right, 2 to the left, 2 up, 2 down. We get all the necessary points we need for sketching a circle. We connect them together and we get the circle. Okay. And last but not least, make sure that on the assessment, you label whatever you sketch out. Okay. Make sure you label them. Okay. All right. Let me erase some things in here, and then let's talk about how to decide whether this equation in here is a function or no. Okay, so according to my tips, first of all, let's isolate y. I'll need y in here, right? So first of all, I need to get rid of the square on top of y, and I also need to get rid of the x squared somehow, right? So first of all, let's minus x squared from both sides. And that will cancel the x squared in here, and then on the left hand side we only have y squared. On the right hand side we have 4 minus x squared. Why? Because we cannot combine them. 4 is a number, x squared is a variable, so we can just leave them together. We can only write them together, and that's all we do. Okay, so make sure you're not trying to like do something like 4 minus 2 because you have a 4 in here and because you have a 2 in here. Don't do something like y squared equals to 2. Don't do something like y squared equals to 1 just because you have the 4 and a negative in here. Don't forget the x, okay? These are the big no-nos. Don't do them, okay? So let me get rid of them before they get into your head. Okay, eraser. Alright, so next procedure, because we want to isolate y only, right? We don't need the square, so how can we free the y from the square in here? We're gonna take the square root of both sides. Okay, and then we're gonna get y equals to plus and minus. Let me use another color to stress this out because it's very important. A lot of people forget the plus and minus, so make sure you remember the plus and minus. Okay, you're gonna ask me why is that so important, and I'm gonna tell you the reason why we have the square in here. It tells us that there's two values of y when you free the y from the square. That 2 in here, it means plus and minus. Okay, it tells you there's two values, one is positive and the other one is negative. Okay, and this one is like one special feature about the square. Okay, so whenever you unsquare something, whenever you take the square of something, make sure you include the plus and minus. Okay. And some of you guys may ask me earlier when I did r squared equals to 4 and then I take the square of both sides. I said r equals to 2, but I didn't say anything about r equals to negative 2, even though this one also have the square. And there should be two values of r's. And I'm going to tell you radius is a measure, right? It doesn't make sense to have a negative measure, right? So radius of negative 2, what does it mean? Does it mean that you go up negative 2? Does it mean you go down negative 2? Or like, what does it mean? It doesn't make any sense. That's why I didn't say anything about this one, because it just doesn't make sense in real life to have a negative radius. Okay? But in this case right here, y in here is not the radius, right? Y is just a variable. Y is just y. Y is not r. That's why make sure you have a plus and minus when you're solving for x or y. Okay? Alright, next step. Let's input something for x. What do you want to use for the value for x in here? It really doesn't matter, but just to make our life easier, let me use 0 for x. In this case, if I plug in 0 for x, I'm gonna get for the square root of 4 minus 0, which is 4, and then square root of 4 is 2. And again, there's a plus and minus in front of the square root, and because I already took the square root, I'm gonna have plus and minus 2, okay? In other words, I have y equals to positive 2, and I have y equals to negative 2. Okay, let me use another color to stress this out again. For one x value, we have two y values. Is that a function? I don't think so. Why? Because by the definition, a function said that for one x value, we must have just one y value. And in here, for one x value, we have two y values. That's bad. That's not good for a function, right? That's why this one not a function. This is not a function. Not a function. Let me put a shortcut for this one because I don't want to write out the whole thing. Okay. I'm gonna show you another like cool way to tell whether a graph is a function or no. If you have a graph already. And a sneak peek for it, or like a hint for it, just like a heads up, is that if you look at a circle right here, let me use pink actually for this picture. If you have, just imagine you have like a ruler, or if you have like a pen, a pencil, you hold it like vertically across the paper. Just imagine this is your pencil. At the beginning, it doesn't touch on the circle at all, right? And then you move it a little bit more to the right. So then it touches the circle once, right? Right here. It touches the circle only one time, right there. But then when you move it more to the right, say, I don't know, right here, then it touches the circle here and here 2 times, right? It tells you that this is not a function because like there are moments when you move the pen across the picture, across your graph, it touches your graph more than once. Okay? Even though there's a moment that it touches the graph only one time, it doesn't matter anymore because at another moment, at another like point, at another like time, it touches the graph more than one time. That screwed it all. Okay? And to make it make sense with what we had in there for x equals to 0 and y equals to plus and minus, let me also draw them in here so that we all know. Okay, so when x equals to 0, we refer to this point here on the x-axis. And then we have y equal to negative 2 and y equal to 2. So that means we have 2 points, right? 0 and 2, and then 0 and negative 2. So it's right here and right here. Okay, if you try to like connect it to the concept, the idea of like moving the pen across the paper, like I just said, just imagine if your pen standing right here. Like at the beginning, your pen is right here and it doesn't touch a circle at all, right? And then as a moment later, a few minutes later, you move a pen across to the right and it touches the circle twice. Right here, at the point of 0, 2 and 0, negative 2. It tells you that this is not a function because it touches a circle. It touches your graph more than once. Okay? If you don't get it, it's fine. I'm going to talk about it later in the next slides, in the next pages. This idea, we call it the vertical line test. Vertical because it's the pen in here is hold vertically, right? Line because the pen represents a line, and test in here is just a testing tool for you. So this is what we call my vertical line test. And we're going to talk about it later in the next pages or even in the next sections. Okay? And before we move on, let me put a green star on this one. This is what you have to do for this page. And let's see. Let's talk about the second objective, the next one. The graph of a function. Okay, here we go. The vertical line test. Okay, so if you still remember what we have earlier, these are the same functions. This one is still a circle. And for graphing, okay, let's read this one out loud first. For graphing, the standard convention is to let the horizontal axis represent the independent variable or x-axis. In this convention, vertical line test is used to determine whether a relationship is a function or no. What does it mean by vertical line test? What does it talk about, right? It says that a set of points in the xy plane is the graph of the function if and only if every vertical line test, every vertical line intersects the graph in at most one point. Be careful with the word in here. It tells you that at most one point, right? So you can only touch your graph once at any moment, at any time that you're moving your pen from left to right. If at any point you touch your graph more than once, it's out. It's not a function. Okay? So this is the same thing that I just told you guys from earlier. So if you have like the pen at the beginning is like right there, it doesn't touch a graph at all. At here it touches the graph once. That's great. It could be a function, but later on, like 1 second later, when you move the pen right here, it touches the graph twice. This screws everything out. Okay, so this threw out the concept of function. So this is not a function. Okay. All right, let's talk about the actual question we have for example 2. Find the domain and range of the following equation. So if you still remember the concept about the domain and range from the last page, the domain here is for the x value and the range in here is for the y value. Okay, so graphically, if you read the graph, this one, where does it go from left to right? Where does it go for the x values? Okay, let me take out this circle because it looks lame. All right, so for the circle, you have everything on the red curve, right? So you have everything, so say on the x value in here, on the x-axis, you don't have x equal to -3, right? Because it's not a part of the circle. You have x equal to -2, you have x equal to 0. In here, you also have x equal to 1. In here, you have x equal to something, I don't know, like -1.5. In here, you have x equal to 1. In here, you have x equal to 2. And in here, you have, I don't know, something like x equal to 0.6. So technically, you have everything from -2 to 2, right? It's not on the x-axis, but it has the value of x-axis from -2 to 2. And if you don't want to look at the top half, you can look at the bottom half. It tells you the same things, right? It reflects the same thing. It tells you that you have all the x value from -2 to 2. So that tells you that the domain in here, it equals to -2 to 2 inclusively. What do I mean by inclusively? You have the value of 2. You have the value of -2. Okay? And by symbol, if you have something inclusively, it means that you have to write it in brackets. Okay? This in here is different from parentheses. -2 to 2. This in here is inclusive. And parentheses in here is for exclusive. Include, it means that you have to. So 2, check. Exclusive, it means that you don't have a 2. So this one, exit out. Okay? So if you remember, like, the function that I told you, y equals to 1 divided by x minus 2, for this equation, you don't have 2, okay? So for 2, you exit out. This is not a part of your domain, okay? Right, let me just take out this example. And then that's the domain. Let's talk about the range. Okay, the range in here. Okay, first of all, let me just box the answer before you like confuse further. And let me take these off the page. Okay, so the range is about the y values, right? For y values, we talk about this axis right there, right? So what y values do we have in here? If you go, say, in here, I don't know, like -4 or -3, something like that, it's not a part of the circle anywhere, right? But if you go up, you have this. You have -2. If you go up more to -1, you don't have -1 on the y-axis, but fortunately you have -1 in here on the circle, right? It is corresponding to the value of -1 on the x-axis, but it's just not on the x-axis. I mean, it corresponds to the y value of -1 on the y-axis, but it's just not on the y-axis. There we go. And if you move a little bit up, you have this equals to y equals to 0. If you move further, this point here has a y value of, I don't know, 0.8. If you move further more, you have this point equal of y equals to 1.2. And up top in here, you have this point of y equals to 2, right? So technically, you have everything from -2 to 2, just like the last time. But it's not about x-axis, it's not about x values, it's about y-axis. It's about y values now. And again, if you don't like to read it from the right of the circle, you can do the same thing from the left circle. This one, it tells you that we have everything from, say, -2 right here, and I don't know, like -1.9, -1.6, and something like that. And at this one, I think it's like 1.1. Up here, it's like 1.6. And up here, you have 2, right? So you will write the same thing. We have the range, R for range, equals to -2 to 2 inclusively, because we do have the value of 2 and -2. Okay? That's one way to figure out the range and the domain. That's by the graph, right? But unfortunately, we don't have the graphs all the time, right? If I don't give you this picture, how can I know what's the domain and what's the range of the equation? Well, we'll do it algebraically. Okay, be prepared. It's gonna be ugly a little bit. Let me get rid of some stuff in here so that we have more space. Okay, if you want to solve for the domain, let's solve for x. And again, what do I mean by solve for x? I mean isolate x. How can I isolate x? First of all, I'm gonna minus y squared from both sides. And then that gives us x squared equals to 4 minus y squared. If you think this procedure looks familiar, yes, it is. It's just pretty much the same thing, same procedure we did in the last example. But in the last example, we did it for y. This time we do it for x. Okay, and then we're gonna have x in here equals to the square root of 4 minus y squared. But wait, this is wrong, because there's a 2, so that means I have to attach plus and minus right there. Okay, so now you have to ask yourself, what, okay, so you have to ask yourself what x value would make sense in here. Okay, so if you put like different numbers for y, say if you put something, I don't know, like y equals to 3, what do we get out of this? We have plus minus square root of 4 minus 3 squared, which is 9, and 4 minus 9, we have a -5. This is undefined, right? Because we don't have square root of -5 unless we have like imaginary numbers, where we don't even talk about it yet, so don't even think about imaginary numbers at this stage. So 3 in here is not a good value, right? Let's talk about another value. I don't know, let's do something less than that. Let's say y equals to, I don't know, 2 maybe. Then we're gonna get plus minus square root of 4 minus 2 squared, which is 4. Well, we have 0 in this case, right? Because 4 minus 4 is 0, and then the square root of 0 is 0. Plus minus 0 is 0, because 0 doesn't even have a sign, right? We don't say we have positive 0, or we don't even say we have a -0 at all, right? It's just awkward. Okay, so for y equals to 2, we have it equal to 0. This is like one x value. That's great, but there could be many more, right? If you plug in different values for y, say, I don't know, something less than that, 1.9, then you will get something out of this. It would be plus and minus 4 minus 1.9 squared. Let me grab my calculator really quick. If you already have a number, that's great. Wait for me. 4 minus 1.9 squared. I have 0.62. Okay, I'm running out of space, so I'm gonna squeeze a 0 right there. This is my ugly 0. Sorry for the bad writing. Okay, and if you plug in another value, I don't know, let's do something way smaller than that. I mean, you can do 1.8 and then 1.7 and then 1.6, but then let's keep the process because first of all, I'm running out of page, and second of all, we don't want to waste your time or your energy on taking every single like decimal, right? So let's do y equals to 1, and then from there we're gonna get plus minus 4 minus 1 squared, which is 1, and we add square root of 3, which is, what is it, 1.73, right? Okay, let's see what happened if we jump again and we have y equal to 0. Then shortcut, you can put this whole thing to your calculator and you're gonna get a plus minus 2, right? So it tells you that you have x from 0 all the way to 2, right? But is it enough? Do we miss out something? Well, remember that this one in here is actually plus minus 2, right? It's not just 2, but it's plus minus 2. And remember that this 0 right here lies right in between 0 and 2, right? Outside this range, I don't think we have any other x value. Okay, so we're gonna close this one with d, the domain, equals to -2 to 2. And I know what you're thinking at this moment. Well, the second method, the one that we have to do algebra for this, is way harder compared to the one that we did when we just look at a graph and it tells us like where x value goes from left to right, right? But I'm telling you, I'm just showing you there's two ways to do it. Okay, so in the test, I think it's gonna be easier than that. I'm not gonna force you guys to do something as hard as this one, but I'm just like teaching you like it could be as difficult as this one, okay? Alright, so as you can see, this process in here, it takes a lot of time because you have to plug in different numbers and sometimes it doesn't even work, right? Just remember the time when we plug in y equals to 3, that doesn't even work, right? Because we have like a negative number underneath the square root. And then you could have tried like 2.9 or something like that. Or like if you're unfortunate enough to start with a big number like y equals to 10, well, you have to end up with a longer way. You have to plug in like y equals to 9, y equals to 8, and then it'll take you a longer time to figure out that, well, all the values of y that is under 2 or equal to 2 would make sense. And everything outside that range would not make sense. But yeah, you know what I say. It's like life is like trial and errors, right? So math is trial and errors. You just have to keep plugging numbers, and then you'll know what to do next. So this one is like a long procedure. I'm gonna tell you like I know from the beginning I'm gonna plug in 2 first of all because I have the graph. I have like sheet ahead of time, so I know the answer. That's why I go with 2 right here because I know that the answer will have 2. For 3, it's just to test you out, just to show you that, well, you could have gone with 3, but then it doesn't make sense. So that's why you have to like go back to something less than 3. And I cheat ahead of time. I could have gone for like 2.8, but like I said, I don't want to waste your time. That's why I jumped directly to 2. Okay. So the biggest secrets of like these problems finding the domain range is to look at the graph ahead of time. Okay. And then from there, when you know the answer and ready, you will go plug in the proper y values to save your time. Okay. I mean, if you have to show some work, right? You cannot say, here's the answer, grade me. That doesn't work for me, right? Like you have to turn some work to me. So yeah, this is where everything goes like a little bit like long and it takes time. Okay, for the range, let me erase some stuff in here. It will be the same procedure, long procedure, in the sense that you have to like plug in different values for x after you isolate it out. Okay, so first of all, let me isolate it out, and just like the last page, if you still remember what we have until we isolate y, it equals to plus and minus square root of 4 minus x squared, right? And in here, you have to plug in different value for x. But like I said, I cheated ahead of the time by looking at the graph, and I know that my y goes within -2 and 2, right? Because we don't have any point outside of the circle that is greater than 2 or less than 2. Unless you like take another circle or take another problem. So I'm gonna be smart about this one. I'm gonna start with -2, and for here, if I plug in -2 in here, I'm gonna get something like Negative 2 squared, which is 4. 4 minus 4 is 0. I'm going to get plus minus 0, which is just 0, right? So this is like the in-between point, right? And if I want to, there are definitely more than one value in your range and your domain. So let me take another value for x. I don't know, something like less than negative 2. I mean, something bigger than negative 2. It cannot be like less than negative 2. Because if it's less than negative 2, you would have to go out this way, right? Which is like nowhere. So let's take something that is bigger than negative 2. Let's do, I don't know, 1.7. Okay, let me get rid of these. Okay, and if you plug this into the calculator, okay, bear with me. This one is going to take some time. 4 minus 1.7 squared. And notice that I put x equal to negative 1.7 in here, but when I plug into the calculator, I'm lazy, so I kind of like drop out a negative. Why do I do so? Well, if you think about it, like positive 1.7 squared, it gives you a positive number, right? And negative 1.7 squared, it also gives you a negative, it also gives you a positive number. So either way, it gives you the same answer. It's just like how you do 2 squared, you get 4. And if you do negative 2 squared, you also have a 4, right? So if you have to write in paper, you have to do this, right? But if you have to input into the calculator and you're lazy like me, if you don't want to put the parentheses, and if you don't want to put a negative in there, you go with this, okay? Alright, so that gives me 1.05. Okay, so let me pick another x value in here. Let's go all the way up to 0. And if you input it in there, in the calculator, you have plus minus. Oh, I forgot a plus minus here. Okay, plus minus there. Okay, 4 minus 0, I have a 4, square 4 is a 2. Okay. And if you go beyond that, say if you want to do something challenge, like 1, but let me skip 1 because I know it's going to work. Let me do 1.7, for example. I'm going to get y equals to plus minus 1.05. How do I get it so fast? Because I told you a little trick. If you input the plus or the minus value of the same value, they're actually the same thing at the end of the day, right? So why do I even bother? They should be the same number. Okay? And again, you're going to end up with this. The range equals to negative 2 to 2. Why is that so? Because the biggest value among all of these values that we just had in here is 2. And the smallest value that we have in here is negative 2. Some of you guys may ask me, why isn't it 0 to 2 or something like this? And I'm going to tell you, negative 2 in here is smaller than 0, right? You have to compare them. So if you have the negative 2, the 2 will have to move out of the way. And you're going to end up with negative 2, 2, 2. Okay? And again, this is the hard process, so I don't think I'm going to test you guys on this one, but I want you guys to at least see why things happen like this, okay? And again, think about a vertical line test is really useful and it's really helpful to help you to determine if something is a function or no ahead of a time, okay? Alright, oh, start. Let me put a green star before I move on. Okay, next objective. 3. Okay, function notation. When using an equation to define a function, you generally isolate a dependent variable, which is y, to the left-hand side of the equation. For example, if we have a function y equals to 2x plus 1, just to like emphasize it out, this one is also a linear equation. Why do I know that? Because there's no power on either x or y. Okay. I like to like recall like some definition that I learned when I see something. That's just my habit. But you don't have to do it, of course. Okay, in function notation, we write f of x equals to 2x plus 1. If you notice, I put y in green, and in blue, and I also put f of x in blue. Why do I do so? Because y equals to f of x. Y is the output, or we call it a dependent variable, but we replace it with f of x 2 tells us that y in here is a function of x. F in here is a word for function. It's shortcut for function. That's why it's f. Later on in the course, you can call it any name that you want to. You can call it like g of x, h of x, or say s of x to go with my name. I guess my name is Selena. That's why I go for s of x. If you are like Justin Bieber, you can also do j of x. It really doesn't matter. This in here in front of the parentheses, they are just names of the function, okay? Just like how people call you by their name. And the variable inside, it tells you that, oh, my input in here is x. That's all, okay? Let me erase some of this again. Alright, so furthermore, if x equals to -3, then we get f equals to -3. Notice that from here to here, we replace -3 by x. We replace x by -3, right? So at the beginning, x in here is in like in between of the parentheses, but then we have x equals to 3. That's why in between the parentheses, we're gonna write -3, not x anymore. Okay. Again, this one is just a plug-in process. Okay, no big deal. And then on the right hand side, we're gonna plug x equal to -3 in here. Okay, so remember, if you replace x by a value on the left hand side, you also have to do the same thing on the right hand side. Okay, and then for this in here, I told you guys already, so whenever you have like a 1 plus 1, make sure you don't leave it as 1 plus 1 for the final answer, right? Don't leave anything hanging. If you think you can simplify it out, do it, right? So we know that 1 plus 1 is 2. That's why if you have 2 times -3 plus 1, make sure you give me a -5, okay? Don't leave the question hanging. Alright, and then to end it up, we say f of 3 equals to -5, and they are both called the function value, okay? So again, x in here is the input, and whatever number you get out for an x value, we call it a function value. So let me highlight this one out first before I forget it. Function value. Or technically, if you want to think about it, it's just the y, okay? But in number instead, okay? So my example, evaluate the following functions when x equals to -3.8, -2, 0, square root of 2, and lastly, a minus b. I know what you think. There's so many of them. There's 5 of them. Well, I have to do 5 of them. Well, promise you it's going to be fast. Okay, let me take out all the like mark that I have in here. Alright, so we have a function right here. And again, let's do x equal to -3.8 first. Okay, how do I do this? Well, I'm gonna plug in -3.8 for x, right? So I'm having f of -3.8. Give me 1 second. Let me connect this. Okay, f of -3.8 equals to square root of -3.8 square minus 2 minus 1. Okay. Wait. Last on the way to -2. Okay, and if you input this into the calculator, let's see what we get out that. Sorry for the noise. We're gonna get approximately 2.53. Okay, and if you want, you can do the same thing for -2 and also for 0 for 2 square root of 2. Okay, the special thing about a minus b, the special thing about it is like why I want to include it in there. It is because notice that for like the 4 cases that we did previously, they're all numbers, right? But for a minus b, that is a letter, that is a variable. And how can we deal with variables in here? Well, we pretty much will do the same thing, right? We don't do anything like different. So I'll do f of a minus b because we have x equal to a minus b, and then we have the square root and then a minus b in here, square minus 2 and then minus 1 outside of the square root. Okay, and this is the answer. So you might ask me, well, why don't I like extend it further? You actually can do it. You can do a minus b times a minus b, and then if you remember what FOIL is, FOIL them and then put negative to next to it. But what's the point of doing that, right? We cannot simplify it any further because a minus b, they are just variables, and we cannot do anything with variables. That's why I'm just gonna leave it as what it is in the box. While for the other like number, I have to do it in the calculator. I cannot just leave them as like work undone, okay? Alright, so I leave the graph in here. What is it for? I want to show you guys a function of it. So let me draw it out real quick. You don't have to draw it. So if you use like Desmos or GeoGebra, the function, it will look like this. Ish. My drawing is bad. And then from here, first of all, let me take out some of the things in here. Alright, so the very first point, I think this one is equals to 2.53, let's remember it. So for x equal to negative 3.8, y equals to 2.53, right? It is right here. So the graph in here, you don't have to draw it, but this one is just to confirm with you that for every x and y value that you get, like corresponding to each other for like algebraically, it should be very sensitive in the graph. Like that should be a point in your graph. It's not gonna be like outside of the graph. That's what I mean for like putting it there. Okay, and then let's see, if you plug in, say f equals to 3.8, you will have something, but guess what, it's not going to equal to 2.53. Actually it is. Forget what I just say. Yeah, this one is just the same procedure, so you're going to get the same thing as 2.53, and it's actually on the other side of the graph, so it's like right here. Okay, and okay, earlier I introduced you guys the concept, the test with vertical line. Why not horizontal line, right? So just imagine if you have a horizontal line test, which I'm gonna introduce you guys in the next minute, and let's use it. So this time you have a pencil, but let's put it horizontally, okay? And you're gonna move the pencil from the bottom to top of the graph. Just imagine at first your pen is right here. It has no contact whatsoever with the graph, right? And then the next second, your pen is right here. It touches the graph at 2 points, one in here and the other one in here. And if you want to make sense with like these two values that we just did, the pen, just imagine it touches the graph right there and there. So what does it mean? Is there anything special about this one? So I told you guys, like if we move a pen vertically across the graph from left to right, if it touches the graph more than one, then it's not a function, right? Then what does it mean if a pen, when we move it horizontally from like bottom to top, touches the graph more than once? Well, then the function is not 1 to 1, okay? Definitely, I'm gonna put it in words, and I'm gonna show you guys the definition of a horizontal line test. But for now, keep in mind that horizontal line test is for 1 to 1 function. Remember that it's already a function, and we're testing the property of 1 to 1, okay? And then the vertical line test is not like yet known as a function or not. That's why the vertical line test, we want to test whether it's a function or no, okay? So, first of all, this is green star for your part. Okay, for your part, we're gonna have a absolute value function. Okay, I don't input the graph in here. If you want, you can draw it by plugging points. I will suggest using the 5 points that I gave you the last time with the quadratic equation, which are x equal to -2, -1, 0, 1, 2 for the system, to get a 5 points, at least 5 points. If you want more, you can do that out of this function, and after that sketch them out for like connecting other points together. You will see that it looks like a V shape, but especially for your problem, it's gonna look like a downward V. Okay, it's gonna look something like this. Okay, I'm just like draw like randomly on the graph. It doesn't have to be there on the actual graph. If you're lazy, you can use technology. I mean, it's there for us to use, right? So if you go to Desmos or GeoGebra and input this function right here, I will show you the graph of your function, okay? And because I already mentioned one-to-one function, okay, let me just put like the conclusion that this is not one-to-one function. So we know that the graph, this graph in red is a function, because for every like orange pen that I go, I only touch the graph 0 time or 1 time, right? It never more than once, okay? But it doesn't pass the horizontal line test. So this is not a one-to-one function, okay? So this is not a one-to-one function at all. It's a function, but it's just not one-to-one, okay? So now what does it mean by one-to-one function? It means that if to each value of the dependent variable in the range we refer to y value, there corresponds exactly one value in the independent value, which is x. So for every one y value, you only can have just one x value. If you have more than one x value, you're out. It's not a one-to-one function anymore. It's still a function, but it's just not one-to-one, okay? Geometrically, a function is one-to-one if every horizontal line intersects the graph of the function at most once. Okay, so this is what I just told you about, like the pink line, the horizontal line test with the red graph earlier in my picture. Okay, and let's move on to the next one. And remember one thing, if like anywhere in the lecture, if I talk too fast or if there's something that I confuse you, that you don't understand, you don't know, let me know, okay? Just email me or like text me and group me so that I can explain it to you again, okay? And this one is not like one of the objective, but just like I saw it in the homework, and I saw this one as one of the problems for your homework. So I just want to give you a little bit guide to help you out with the homework, because I know that it's hard. Been there, so I know that it's hard. Okay, some question might ask you about the different ratio, and this is the formula for the different ratio. Ratio because it's a quotient. Well, different quotient. Quotient, ratio, fraction, they're the same thing pretty much. Okay, so if you see any of the 3 terms in there, they're the same thing. Difference in here because on the top part we have like difference, subtraction. That's why shortcut we call it different quotient. Difference for the subtraction, quotient because we have a fraction. Okay, so this one is a formula. You don't have to remember it. I'm gonna provide it in the assessment if you ever have it. I think you're gonna see it a lot, especially later on when we talk about derivatives and integrals. But for now, make sure you have it down somewhere in your paper, okay? In like your sticky notes or postage somewhere in the room, okay? Make sure you have it down. Okay, and in here, this triangle in there, please don't call it triangle. We call it the change. For example, delta x in here is a change in x, and if you have a delta y, it's the change in y, okay? What do I mean by the change in x, and what do I mean by the change in y? Say, if you have x equal to 1, I mean x1 equal to 1 and x2 equals to, I don't know, like 10, then delta x in here, the change in x in here is 9. Why is that so? Because I do 9 minus 1, right? So this one is just like the difference, or if you want to use some fancy word, you use the change, okay? And let me get these out of the page, because these just like for the concept of delta, the change in x, or the change in y. Okay, this concept comes from the meaning of slope, and it's very important in physics and calculus. So if you're like an engineering major or anything that has to do with like science, make sure you remember this formula right there, because it's really important. Okay, so in the problem they will give you something like a function, and they're gonna ask you to find the different quotient. And what you're gonna do in here is that first of all you need to identify f of x plus delta x. So if I remember what I told you of like the things in between the parentheses, it's x, right? It's from like earlier page. from the last page, I told you whatever like after f, whatever after the name of the function, but in parentheses, like in between the parentheses, they mean x. They just stand for x. It means that for x plus delta x, we're gonna plug it in for x of the original function, and then we have this. Okay, so if you compare this function that the problem gives us to the one that I write down in the different quotient first of all, they pretty much the same, right? Except that we don't have x anymore. In the place of x, we have x plus delta x, okay? And then we have the minus just because that's a part of the equation, that's a part of the formula. And after that, we have f of x. Remember that f of x is always given by the equation, so we just have to copy it down in here. And on the bottom, we have delta x. We have the fraction is a part of the formula, and delta x is also a part of the formula. Okay? So now we're going to break out all the parentheses. Okay? So this is gone, this parentheses is gone, and this parentheses is gone. But because we have a subtraction in between, so let me put it in a different highlight. Okay, so this negative is distributed to the first term and also the second term, right? So that's why the first term is negative, and now the second term is also negative. Notice that from the beginning, we have a positive 2, but when we break out the parentheses, we distribute the negative into the 2. That's why we have a negative 2 in the second line, okay? And everything else, we just have to rewrite them. It's just the same thing. Okay, this one is a big step. This one is the hard one. All right, how can we know what to do next? How can we move on from here? Well, whenever you see the square root in there, the only thing that you can do is a conjugate. Okay, if you want to look up for some worksheets, some example, you can Google conjugate worksheets, and then you can have more practice on this one. This is hard. This is like one of the hardest thing that I used to learn. That's why I have to like stress it out to you guys first. And what does it mean by conjugate? It means that if I give you something like a plus b, the conjugate of it is a minus b. Another example, if I give you something like negative a minus b, the conjugate of this is negative a plus b. Okay, so notice that for conjugate, we only change the sign between. If this is plus, then this is negative. If this is negative, then this is plus, okay? We're not going to touch any other like sign for this one and this one because it's not in between the two terms that we have in here. We don't touch them at all. Conjugate, it's just about the middle sign. Whatever sign you have in between the terms, we change them. Aren't that? We keep them. Okay? So first of all, we figure out the conjugate of the top part in here. Let me put it in blue. So the conjugate of this is this. Okay? It's too long, so I'm not going to read it out. But technically, if you see this one, the only thing that change on the top parts in here are the plus and the negative because they are conjugate of each other. Okay? Those are bad circle, but then you can see that like the two sides in a circle, the first one is negative and the second one is plus. Okay? I think I can do a better job. Okay, so let me do circle in here. Okay, negative and the conjugate of it, we have plus in there. Okay, there we go. That's better. And then after we identify the conjugate of the square root or like the numerator in this scenario, we can multiply that conjugate, that whole like junky thing, to the top and the bottom of the fraction. So let me use the highlighter in here again. So if you notice, the top and bottom, they are the same thing. They have the pluses in here because they both are conjugate of what we originally have. Okay? And after that, well, we just have to do FOIL. So first, last, in, and then out, inside and outside. Notice that on the bottom, we don't do anything but putting them together, okay? So make sure you don't distribute delta x to any of the terms on the second fraction, okay? Well, you can actually do that, but like to my experience, that delta x will eventually be gone somehow soon. I'm gonna teach you guys how to like make it disappear, but at least for this moment, don't touch on delta x at all, okay? Like whatever you do for delta x, that black delta x on the outside, don't touch it, okay? Alright, so after you FOIL the tops and then you simplify it, and then you're gonna get this new expression in here. And a hint for us to like simplify after we FOIL it is to use the formula that a squared minus b squared equals to a minus b times a plus b. This is one of the formula, like big formula that we learned from, back in the day. But if you don't remember it, it's fine. Okay? And after that, PEMDAS, right? We're going to simplify the expression by distribute the negative, by breaking out all the brackets in there. And if you have a positive or like a plus in front of the brackets or parentheses, you keep everything. If you have a minus, if you have a subtraction, if you have a negative number in front of your brackets, make sure you distribute it. For example, this one is a negative, so make sure you distribute it to x and negative 4. Okay, so it's going to be negative x in here, and it will be positive 4 in here. Okay, after that we simplify, right? X minus x canceled out. Negative 4 with 4 canceled out. So on the top part, we also have delta x. We only have delta x, right? And like I told you before, this delta x on the bottom will disappear. Why? Because eventually it will cancel with the delta x on the top. Okay? And these two cancel to 1, right? Make sure that they don't disappear, right? So some people, they rewrite the whole bottom down, but as like no fraction, they just write square root of x plus delta x minus 4, and then plus square root of x minus 4 just by itself. That's wrong, okay? Remember, the position of this whole term in the beginning is at the bottom of the fraction, right? So when you cancel out the delta x, it has to be at the bottom of something. It cannot stand by itself, okay? So that's another common mistake. Make sure you don't make those common mistakes during the assessment, okay? And lastly, this could have been the answer, but if you want to go further, if you want to plug in 0 for delta x, you're going to get this, okay? And this is actually like one of the ways to find out the derivative of a function. We're going to learn later, okay? But for now, just focus on a different quotient. This concept, this page is really hard to me at least. So if you have any questions, let me know, okay? Probably you're not the only one who have this problem, okay? And again, there's nothing to do on this page because there's no example. There's no other like work to do. So just make sure you read it and understand it well. If you have any questions, let me know. Okay, next page. Combinations of functions. Two functions can be combined in various ways to create new functions. For example, if I give you the first function, say something easy like, I don't know, x plus 1. And the second function, if I want to call it g of x, because again, these are just names, right? You can call it a of x, b of x, c of x, whatever alphabet letter of your favorite. You can just do it out. And the second function, let me do x squared. Okay. Originally, this one is one function by itself, and this is one function by itself, right? These two have no relationship whatsoever to each other. But if you want to create another function, well, we can actually add them together, right? Like if you add them, you will have another function. It's not f, it's not g. Let's call it, I don't know, n of x for new function. If you add them together, none of these variables will like add up with each other because x squared is x squared, x is x, 1 is 1. They're not on the same category, they don't have the same power, they're not the same type. So eventually we can just rewrite them next to each other. So we have x squared plus x plus 1. Okay, this one, it doesn't listen. Okay, there we go. That's my ugly one. Okay, and if you notice this new function in here, it doesn't even look like f like completely, and it doesn't even look like g completely, right? It has a little piece of f, and it has a little piece of g, but it doesn't completely like exactly look like any of those. Okay, so this is a new function. This is what I mean by creating new functions earlier. Okay, and if you don't want to add, you can multiply these two functions, you can divide these two functions, you can subtract these two functions. I don't know, there's like various ways to combine these two functions, whichever of your choice, to create new functions. Okay, all right, definition: the function given by f of g of x. Okay, the little circle in here is like, if you want to call it in the fancy word, you can call it composite, or just like me, if you wanted to call it a normal way, f of g of x. Okay, the little o in here is like off, because off in here is start with the o, so f of g of x is just f and then circle g and then x. Okay, it's the same thing as this one. If you like drop out a circle, that's fine, but make sure you have enough parentheses in there. Notice that there's a parenthesis between F and G, and there's also another pair of parentheses between G and X. So between each layer, there are parentheses, okay? Don't write something like this. Okay, this is ugly, this is weird, okay? Don't write it like that. Okay, let me get it out of your head first. Okay, so f of G of X is the composite of F with G. In other words, you just like plug G into F, okay? And the domain of F and G, the domain of F of G is a set of all X in the domain of G, such that G of X is in the domain of F. Okay, you don't have to understand too much about this one, to be honest. It's lengthy, but like by the first example, by example 4, by if you like see what I do after my part, you understand what it means by that sentence. Okay. All right, so let me do it out first. Okay, I know these are hard. Like personally, I pick on the hard problems because these are just my practice. So that's why I want you to challenge yourself with some like hard problems first, and then on the homework it's gonna be easier than this. Okay, but don't worry at all. You're not gonna see any of these in the test. It's not gonna be as hard. Okay, you will see these concepts, but you're not gonna see these hard problems on the test. Okay, so don't freak out. Okay, green star for the part you have to do. All right, red. If I want to find f of G of X, first of all I'm gonna treat G of X, like the whole thing, like X. What do I mean by X in here? I mean this X and that X in the first function of F. Okay, so first of all, let me get rid of this. Okay, so I have f of G of X equals to 1 minus, let me leave it blank in here, and then 2 open parenthesis, and let me also leave it blank in here, and then minus 3. Okay, so what I just wrote in here looks exactly like F, right? But I just leave out the X part because I told you guys that X in here will be replaced by G function. Okay, so because G function, it comes in a group, so make sure you put them in parentheses. Okay, so in place of X, I'm gonna write the whole G function. And G function in here is X minus squared 4X squared. Okay, I'm running out of space. Let me get rid of that parentheses, and then plus 5, and then close parentheses now. Okay, and in here also, to replace X, I'm going to write X minus squared of 4X squared plus 5. Okay, the 5 has to be inside the parentheses, but I'm running out of space. So let me just do it like this. There we go. And this is my 5, my weird 5. Alright. Unfortunately, we cannot simplify this one further because it looks ugly enough, and I'm pretty sure you guys don't want to touch it. If you ever want to simplify this one, you can distribute this negative into X and into the second term of it. But like I said, this is ugly and it goes nowhere, so you don't have to do it. Okay? In other scenario, in your case, though, you have to simplify it because it is something that you can simplify. But just fix me if I'm wrong. Just correct me if I'm wrong, okay? In your case, it might not be simplified, okay? But like in another scenario, for example, if I give you something like f of x equal to, I don't know, like x plus 1 for easy, and then g of x equals to, I don't know, x squared, just like last time. Okay, and I asked you to find f of g of x. Then again, first of all, I'm going to rewrite my f function, which is x plus 1. But instead of writing x plus 1, I'm going to space out some space for the x. I'm not going to write anything for x. I'm just going to rewrite everything that's not x first. And in place of x, I'm going to rewrite g. And make sure you to put like g in parentheses. Why? Because usually g comes in a group. For this one, for this example in orange, g doesn't come in a group because it just like has one single term. So with or without parentheses is fine. Actually, with parentheses, you have to like break it down, so that's more work. But yeah, just keep it as a good habit, okay? So this is like how you simplify it, okay? Alright, and you can do the same thing for g of f of x. It's gonna be like super lengthy, that's why I'm not gonna do it here, but in the homework you will see how you have to simplify it, okay? And then the last part, we have to find f of g of 0. Okay, let me get rid of the orange example first. If you ask me why I write like nicely at the beginning, but then I write like really ugly, like right here, it's because my pen, it runs out of like battery. That's why I have to use my finger, and this is, you know, horrible. And my apologies for this. But yeah. Alright, last part in here. Let me put it in orange again. Okay, so how can I do f of g of 0? So remember that usually we have f of g of x, right? But now we have f of g of 0 instead of f of g of x. So this 0, it tells us that x equals to 0. Okay? It's just simple meaning. Alright, so what we're going to do in here, so instead of having x, we're going to have 0. And literally, everywhere you have x, this is 0. We're going to replace them all by 0. Okay? So, if you plug everything in the calculator if you want to, or you can do it mentally, you will get 1 plus square root of 5. And down the bottom, we're going to get negative 2 square root of 5 minus 3. There's actually another easier way to do this one. So this is one way to do it, right? Like you find f of g of x and then you plug in x equal to 0. That's one way. Here's the second way. And in the test, if you have this problem, you can do either way, okay? You don't have to do 2 ways. You can do the first way or the second way, whichever way that is more comfortable for you, okay? So the second way, first of all, you're going to do the inside layer first. So you do g of 0. And g is given as x minus square root of 4x squared plus 5. So if we plug in 0 in there, we're going to get 0 and then minus 4, 0 times 0 squared plus 5. So all of this should tell us that this is negative square root of 5. Okay, this doesn't listen. Sorry for that. Okay, here we go. Okay, so let me get rid of some stuff in here. Alright, let me write it down there. Okay, equals to negative square root of 5. And the square should last to 5. Okay, and now that you know that g of 0 equals to negative square root of 5, you're going to plug negative square root of 5 into f. Why is that so? Because this equals to now f of negative square root of 5. Notice that I plug in, well, in place of g of 0, I write it as negative square root of 5 because they are just the same thing, right? Because we kind of like evaluate, we do it out for g of 0 first already, so I just got a value and then I plug it back into the outside layer, which is f in here, okay? And in f, we have this function, this nice function that I just have so many marks on them. Okay, that one. If I plug into there, I'm going to get 1, and minus minus, that's a positive, so that's a plus square root of 5. And then over 2 square root of 5 is negative, so it has a negative in front. And then minus 3. Okay, so this is it. There's 2 ways to get like the same answer, okay? So you can do it in 2 ways in the test. Make sure you like do it out properly. And another note before we move on to like the last objective of the day. And again, I'm really sorry for the bad handwriting in this video. The quick note is that if you solve for f of g of x and if you solve for g of f of x in your example, you will see this conclusion that I have. Let me put it in pink. Okay, so the thing that I want to point out in here is that f of g of x, it is completely different from g of f of x. Okay, some scenarios you might have them equal to each other, but that's not like the case. That happens like always, right? So because these two are different functions, the domains will be also different, okay? All right, let's talk about the last objective of the day. Inverse function. I can guarantee you that this is gonna be on the test. Oh, one more thing before I move on. Okay, you guys might ask me like why didn't even say anything about this picture right here. Well, this picture right here tells us that if you have like f of g of x, and technically you're gonna plug in you're gonna plug in g into f, and to get the function of f of g, and then the remainder there will be, you know, depending on f and then g technically. I mean, if you want to stare at the picture, like later on you're gonna get some meaning of it, but to me it doesn't like say too much. That's why I'd rather do the work. But if you have any question about this picture, this diagram in here, let me know, okay? I can explain it in more details, okay? Okay, last objective. Okay, remember to focus on this one because it's gonna be on the test, it's gonna be in your quiz, okay? Let f and g be two functions such that f of g of x equal to x for each x in the domain of g, and g of f of x equal to x also, but for each x in the domain of f. So just to point out in here, okay, red, I need red. Okay, this one, as you can see, g in here is the inside layer, right? That's what we're talking about the domain of g. And in here, f is the inside layer. That's what we're talking about the domain of f. Okay. And then in each case, we're going to have the same answer for each of them. We're going to have x and x. These are actually the special case because chances that they're not going to always happen like this, right? So under these conditions, the function g is the inverse function of f. We denote g as f inverse. This one is not the reciprocal at all, so make sure you don't confuse it with the reciprocal. It's just like the symbol for f inverse, okay? So don't call it f negative 1, okay? Just call f inverse. Okay, the domain of f must be equal to the range of f inverse, and the range of f must be equal to the domain of f inverse. In other words, d of f, the domain of f, equals to the range of f inverse and vice versa, okay? So now, say if you have a value, if you have a variable x, you plug it into a function called f, you're gonna have f of x, right? And you throw that whole function f of x into another function g, right? Then the f would be inside your g function, okay? And if you like simplify the word, you do it out, and then you end up having x. Okay, that's not the right way to box it. X. Then this is the inverse function of each other, okay? Then we're gonna say f and g in here, they are inverse function of each other. Okay, so that has a lot of testing in there. You have to plug in g into f to figure out if the answer is x or no, and you also have to plug f into g to figure out if you're gonna have x or no, okay? Usually one word will be enough. You just have to do either this or that, but if you want to rest assured to know that f and g are inverses of each other, I will recommend doing both, okay? Informally, the inverse function of f is another function, g, that undoes what f has done, okay? I'm going to show you what it means by undoes in the example in a second, okay? Not every function has an inverse function. In fact, for a function to have an inverse function, it must be one-to-one. So if you guys don't remember the concept of one-to-one, it's like the function, let me draw an example. Let's look at this one, the parabola. How do I know that this is not a one-to-one function? First of all, it passes the vertical line test, right? So if you draw any vertical line at any point of the parabola, it only touches the parabola once, right? And here and here and here. Only one time, regardless the position of your pen or of the vertical line that you have. But say for example, if you do the horizontal line test, you will have more than one time where your horizontal line passes the graph two times, or should I say more than one times, right? So this is not one-to-one. It's a function, but it's not one-to-one, okay? So for one x value, no, for one y value, you're gonna get two or like more than one x value. That's what it means by not one-to-one. Okay, so for this case, the parabola, this parabola in here, it doesn't have an inverse function, okay? All right, graphically, the graph of the inverse function, f inverse, is a reflection of the graph of f in the line at, y equals to x. This one, if you draw the two functions out, it just happens to be like that, okay? It's like one of the property of the inverse function. Okay, here's some tips. To find the inverse function, we replace f of x with y. That's first step. Second step, we interchange x and y. And third step, we solve for y. Okay, so if there's anything you have to remember in this page, it would be this last line in here. So make sure you understand this procedure. Make sure you remember it. Okay? All right, let's do that out. Okay, so first step first, we replace f of x by y. So in here we have f of x, we're gonna do y for it, and then we rewrite everything else. So we have square root of 9 minus x squared. Done, right? So this is done. The second step, interchange x and y. So we have x in place of y, and we have y in place of x. Okay, second step, done. Last step, solve for y. So we need this y, right? So we need to get rid of the 9, we need to get rid of the square root, we need to get rid of the minus in front of y, and we also have to get rid of the square, okay? A lot of things to do. Well, first of all, to get rid of the most outer layer, the square root, we're gonna do square both sides, okay? So the square will cancel with the square, and we end up having x squared equals to 9 minus y squared. Next up, we're gonna minus both sides by 9. So this canceled out. Okay, let me move a little bit ahead like this. Okay, and then we have x squared minus 9 here equals to negative y squared. Okay, let's multiply everything by negative 1. So x squared times negative 1 is negative x squared. Negative 9 times negative 1 is a positive 9. And then negative y squared times negative 1, we have a y squared. Okay? And lastly, to cancel the square out, we're going to do the square root. So this cancel with that, and then put a square in there. So we have y equals to square root of 9 minus x squared. Okay, some people might ask me, like, why don't I just copy this one and write it down here? And I'm gonna tell you, like, personally, I don't like it to have like the negative in front. That's why I kept like move the 9 and the negative x squared in here. But that doesn't matter if you just give me like y equals to square root of negative x squared plus 9. This counts too. This works too. Okay. So that's also a good answer. Okay, so this one is the final answer. Oh no. Okay, there we go. Let me box it out to make it official. Alright, so like what I said earlier, there's a 4th step. Okay, I know that there's 3 steps in here, but there's 4 steps, right? We have to check it. So make sure you check it with GeoGebra to see if your graph, the original graph, this one, and this inverse function are reflecting through the line of y equals to x. Okay, trust me, it's always true. It's like 100% true for all the time. Okay, and the second way to check this one is that you can do f of g of x. And again, this tells you that g of x will be replaced by will be for like in place of x for the in the function of f. So again, I'm gonna rewrite a whole function of f, but then I'm gonna say some spot for x. So I have square root, I have the 9, I have the negative, I have the square, but instead of x, now I'm going to rewrite a whole function of g, which is this one. This is g, okay? The inverse function of it is g. Or if you want, you can call it like, I don't know, f inverse, because that's the inverse function for it. Or if you want to call it g, I will understand it. Alright, so I'm going to put square root in here, and then 9 minus x squared. So, like what I said earlier, the square root will cancel with the square. So this equals to the square root of 9 minus parenthesis 9 minus x squared. Okay, I need more space. Okay, and this equals to the square root of 9. I'm going to distribute the negative inside. So that makes negative 9, and then plus square root of plus x squared. And then the two 9's are cancel. And I end up having square root of x squared, which is x. Okay? And some of you guys may ask me, well, I have the 2 in here, so why don't I have a plus and minus? And I'm going to tell you, we're not going to have the plus and minus in here. We only have the plus value. Why? Because if you look back at the problem, there's one information that we haven't talked about. This one. X must be in between 0 and 3. That means X must be positive, right? That's why I disregard the case when X equals to negative. Okay, so earlier when I have like earlier when we have square root of X with plus and minus in front, I told you guys we don't have to do this at all. We just have to do square root of X because of this condition. Okay, so this is a part of the problem, but then we never actually touch it. It's just a condition so that we have this in here as X, just to verify that they are inverses of each other. If you draw the graph, you will see why, because if you like don't have this condition in there, it's not going to be one-to-one function. If you open to more like numbers on the domain, it will not be a one-to-one function anymore. Okay, so green star for your part. And again, I'm really sorry for the bad writing in this lecture, but again, if you have any questions or any concerns, let me know. Okay, thank you for your listening, and bye bye. Take care.